This video is explaining direct and inverse variations. Direct variation versus inverse variation, they are inverses of each other, so they are the opposite operations. So the equation for direct variation, direct also means that they are directly proportional. The equation for direct variation is y equals k times x. Whereas inverse variation would be y equals k divided by x, because they're the inverse operation, so it's a multiplication and this one is division. Now what's important to notice is that the x, the variable, is being changed. Right now we're multiplying by the variable. On this one we're dividing by the variable. So that means that your k value, your number, will be on top. Also, the thing you need to notice is that there is no addition or subtraction on the equation. So there is no b value. If I'm looking at this is linear, kx would be like y equals mx, but there is nothing added or subtracted. The same thing over here, there's nothing added or subtracted to the outside of it. Now, when it asks for the other symbolic form, this is another way of saying different but equivalent symbolic form. What that means is that you actually want to get k alone. You want to get the k value alone. So we're actually solving for k. The reason we want to know that is so that you can find your k. So in this one, for the direct variation, you would actually do the inverse operation to get k alone. So it's multiplied by x, so you would end up dividing both sides by x. So k would equal to y divided by x. Now you must be very careful because this does not mean it's an inverse variation. This, even though you're dividing by x, your x and y, your two variables, are on the same side, which is not determining if it's direct or inverse. You have to have your variables on opposite sides, so one on the left, one on the right, to determine if it's direct or inverse. So the other different but equivalent symbolic form for inverse, if I wanted to get k by itself, I would have to multiply by x on both sides. So my k would actually equal to y times the x. That's how you actually would find the value of k if you were given an equation. Now, what is k? K, this is where k is a constant of variation or proportionality. So constant of variation or constant of proportionality. What that really means is that k is a number. Now k is any number. K is any type of number. That means that it can be a 2. K could be a -4. K could be the square root of 3. K could be pi. K could be a fraction. It could be 2/3. K could be a 1/4. K could be a decimal, like 4 8/10. It can be any type of number. Now, what is so very important about your constant is that k, in order to know your constant, because it can be fractions, you have to know what the top and bottom is. You must always, anytime you're finding your k, it always must have a top and bottom to your number. Because if you don't, then you might say the k is supposed to be 1/4. You might just say that k is 4. K has to be the top and the bottom number. Top and the bottom number. So if the top number, if all you have is a top number, that's fine. But if all you have is a bottom number, that's not good, because you have to have a numerator every time. So some important information about direct and inverse. We're not going to do any math yet. This is just understanding the information about it. So we have the equation for direct and inverse. So if we're looking at the equation, we can tell the difference between them. But we also need to be able to tell the difference between graphically and looking at a table of values. So for direct variation, for graphically, direct variation should be a continuous graph. Continuous graph. An inverse variation would be a discontinuous graph. Discontinuous graph. That means that it's split. Discontinuous means it is split apart. There might be two sections to it. There will be what's called asymptotes. 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 A continuous graph won't have that. Now, the other thing about graphically is direct variation. Because it is linear, or it's going to be in the format of almost linear or quadratic, but it's continuous, but it has to go through the y-intercept at 0, 0. Y-intercept at 0, 0. Because there can't be anything added or subtracted to it. So it has to go through the 0, 0. Has to go through 0, 0. However, on an inverse variation, there's actually no meaningful y-intercept. No meaningful y-intercept. Now, sometimes you actually won't even have a y-intercept on here, but if you do, it doesn't actually, it's nothing from the equation. The equation won't tell you what your y-intercept is on here. So the y-intercept, where it crosses the y-axis, doesn't actually mean anything to the equation. It's just where it happens to cross. Okay. So the way it will look, so for a direct variation, the way it'll look, it'll be a continuous graph, and since it's y equals kx right now, this is going to be a linear function because our k, it's just going to be k, it's going to be a number, but our exponent on our x is a 1. Now, you can have what's called power models to where you have exponents that are bigger than 1, which will just change the shape of the graph, and it will change if it's going through quadrants 1 and 2, quadrants 1 and 3. Or if it's your k is negative, it'll actually go through quadrant 4 and then 2 and quadrant 3. So if your exponent is a 1, you have to start in quadrant, you have to have opposite quadrants. So your graph will actually go through quadrants 1 and 3 or quadrants 2 and 4. That's if your exponent is an odd number. If your exponent is an even number, like a 2, 4, 6, your graph will have to go through quadrants 1 and 2 together, or they would have to go through quadrants 3 and 4. It's like if you think about x squared, it would go through 1 and 2 because it's a parabola. Or if it was a negative x squared, it would go through quadrants 3 and 4. What changes where it starts is if it's positive or negative. If it's positive, it has to start in quadrant 1 and then go to either 2 or 3. If the original function is negative, then it has to start in quadrant 4 and then either go to 2 or 3, depending on which odd or even you have. So since I'm dealing with an odd exponent of 1, and I'm just going to say my k value is positive, it has to go through 0, 0. I'm going to just draw a line. It's going to go through 0, 0. So this is a shape of a direct variation because it goes through 0, 0, and it's a continuous graph. Now, this end behavior, what this is meaning is as x's are going to negative infinity, so as x's go left, for this particular graph, my y values are actually going to be going down. So for the range, y values going down would be meaning going to the negative infinity. Now, as x's go to positive infinity, that means as the x's are going right, which direction is the arrow pointing here? It's going up or down? So it's going up. That means that my y values will be going to positive infinity. That's end behavior. This could also be written as f of x. So as x goes to negative infinity, f of x goes to negative infinity. Now these can change depending on which way your graph is going. So you just have to make sure you know as x's are going left, is your graph also going up or down? So if you look on this side of the graph, on the left side of the graph, is your arrow pointing down or up? And as it's on the right side of the graph, is your arrow pointing down or up? Now, in an inverse variation, the graph, again, it's a discontinuous graph. There's going to be, again, what I said, asymptotes. And most of the time, ours on here will not have a y-intercept. but actually there's going to be an asymptote on the x-intercept as well. So for what we're working with, we're going to have a discontinuous graph where it will not cross the x or the y-axis. So in order for that to happen, if I'm going to keep it in, let's say, quadrant 1, so it's positive, but if you have an exponent of 1, it's an odd, it means I have to have quadrant 1 and quadrant 3. If it was a k over x squared, I'd have 1 and 2. But so if I'm looking at a graph in quadrant 1, it has to be discontinuous. So I have to have two parts to the graph. I have to have something on the left and on the right. If I can't cross the x and y axis, I can't make it go this way. I have to actually curve it along the x and y axis. This is what's called an asymptote because it's not crossing the x-axis. It's going to get closer and closer and closer, but never touch it on that y-axis. Same thing with the x-axis. It gets closer and closer and closer to 0, but it never actually touches it. So on the second half of the graph, again, since I have an odd exponent on my x, it's a 1, I have to go to quadrant 3. So then I'm going to mirror that where it won't cross the x-axis, but it also won't cross the y-axis. And this is it's a discontinuous graph because you had to pick up the pin to be able to graph this. Now the end behavior on here is slightly different. As x's go left, so as it's going left, the y values are getting closer and closer and closer to 0, but do you notice that they will never cross over and keep going up? So these values, that's what the asymptote is. It'll make it not cross that x-axis. So that means that the asymptote tells me that the y values are actually going to 0, but never actually touches it. It says the y values are going to 0. Now, as the x's go to the right, so as I keep going to the right, it's going to keep going down, 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 but it will never cross the x-axis. So that means that, again, it's going to the y equals 0, but never actually crosses it. It's going to keep going to that y equals 0. There's a difference here because these will keep going on forever up and down, but these won't because of the asymptotes, because it's a discontinuous graph. Again, asymptotes. A-S-Y-M-P-T-O-T-E-S. Asymptotes. There's a vertical asymptote and a horizontal asymptote because it doesn't cross the vertical line and it doesn't cross a horizontal line. That's how we can tell the difference between direct and inverse graphically. So we can see it from the equations. We can see it from the graphs themselves. And we can also see it from a table of values. Now, in a table of values, if you're looking at your variables, for direct variation, as long as your k is positive, if your k is positive, for a direct variation, as one variable goes up, so it increases, your other variable will also increase. So as x's go up, so as x's go to the right, y's are going to the right, or up. So you have positive infinity. But if one variable goes down, so if the x's are going down to negative infinity, the y's are also going to negative infinity. So we can also say or down and down, because that's what's happening to the table of values. So they are directly proportional to each other, so they're going to be going up. If the x's are going up, the y's also have to go up. Now for table of values, if you have a positive k value, if you see that one variable is going up, so say your x values are going up, then your other variable, your y's, will actually be going down. Because as this goes to the right, see, as I'm going to the right, my y's are actually going down, and it will keep getting closer and closer and closer to 0, but it will keep going down. Or you can go, if your x values are going down, so to the left, my y values are actually going to keep going up. It'll get closer and closer to 0, but it will never actually cross it. Okay, so by a table of values, if you can see that one variable's going up, the other one's going up, probably a direct. One variable going up, the other one's going down, probably an inverse. Now, those are the three types of representations you can have, is the equation, the graph, and then the table of values. The one that we're going to focus on the most is the equation. So if we're going to be focused on the equation, you have to understand how to determine it from the equation. So let's start down here. We must have a variable on either side of equal sign to determine if it's direct or inverse. What that means is that we have to have a y on the left and an x on the right. So in order to determine direct or inverse, we have to have a variable equal to a variable. That means that we can, now the thing is that we have to have one variable completely alone. One variable must be completely alone. One must be completely alone. Now, generally it's going to be the one on the left will be completely alone, but if it's not, you can get that one on the right completely alone. Just one of them has to be completely alone to determine if it's direct or inverse variation. Okay? And that's what we're mainly going to be focusing on. So these are the three representations of direct and inverse variation, and we're going to be practicing some of these. So the three different representations, they do look slightly different. So that's how you determine if it's direct or inverse.